28, graphing rational functions. If we are told to graph this nastiness right here, which, welcome to calculus, you're going to be doing. They're going to start you easy on these and give it to you in factored form. We've got x minus 7 on top. On the bottom we have x plus 5, x minus 5, x plus 2, x minus 2. We have 2 factors on top, 4 factors on the bottom. This one has a negative out front, and the instructions are graph it. Now, these graphs are sketches, so we just need to get some basic characteristics of the graph on there and sketch it in so we have an idea of what it looks like. So the way you do that, and for starting right now, we're going to do it with no repeated factors. Notice this has an x plus 5 and x minus 5, but not 2 x plus 5s. Also notice that there's not an x plus 2 and another x plus 2 up here. So that when either of those things happens, there's something special you have to do. Actually, once they have the same factor on top and bottom, they cancel each other out, but you end up having a hole in the graph. So it's not that big of a deal. We're not worrying about that right now. We're just doing these with a bunch of non-repeated factors. So start by drawing a number line, and you want to make sure it's big enough to include all of your points. When you have it in this form, x plus or minus some number, you need to go. Get the door, please. You need to go left and right enough to encompass all of the numbers that you have here, because these numbers tell you things. So let's start by drawing in the asymptotes. Do you remember what causes a graph to have an asymptote?
Like an undefined value?
Yes, an undefined value. And how do you get something that's undefined? When you divide
By 0.
by 0. So any value of x that would cause us to divide by 0 is going to give us an asymptote. So in this term right here, x minus 5, what value of x would give us an asymptote? 5. So at 5, we're going to have an asymptote. X minus 2, what value of x gives us an asymptote, or gives us a 0? 2. So we're going to have an asymptote at 2. Right here, we have an asymptote at -2. And this one, -5. So we have 4 asymptotes in this graph. Now what gives us a 0? What would cause this whole thing to equal 0?
0 at the top.
A 0 on top. A 0 on the bottom of the division line gives us an asymptote because you can't divide by 0. A 0 on top gives us a 0 because 0 divided by anything is 0. So if we have x minus 7, what value of x would give us a 0? 7. So 7, we know, so there's a 0 right here. This point is on the graph. And also this one right here, which is 0. So we know that those 2 spots are on the graph, because that's where, because those 2 values of x will make the whole thing equal 0. And by the way, this what I'm about to say is true when there's no repeated factors. On this graph that we're learning right now, anytime wherever we have a 0, the function is going to cross the x-axis at that spot. All right. So we have our asymptotes. We know where it crosses the x-axis. Now we just need to know what it looks like. What are the dominant terms here? If I boil this down, if I were to multiply out the numerator, what would be my highest powered term? If I multiplied x by x minus 7, if I multiply that out,
X squared.
my highest powered term would be x squared. What about on the bottom?
X to the 4th power.
It would be x to the 4th. Now there would be some, blah and blah difference on the numerator would be an x squared, and the most significant term on the bottom would be an x to the fourth. And so we have, and there's this negative out front. What's going to happen? We want to start at one end. Usually it's easiest to start at the positive end and say, okay, where is this graph at the extreme right hand? What happens when, as x approaches infinity? When x is a really large number, what happens to the function? Where's it going to be? It's going to be positive, it's going to be negative. It's going to be a really big number or a really small number.
Big.
It's gonna be
Small.
negative, and it's small.
As x approaches infinity, what's going to happen to this? Okay, let's get rid of the laws here for a second.
It's going to get smaller.
Okay? Because we have a higher powered term on the bottom than on the top, this number is going to get way bigger than this one, which means a small fraction that's negative. So what's going to happen way out to the right here is that we're going to be right up to the x-axis. Now we don't have a zero way out here, and so the x-axis ends up being an asymptote way out here. So we're way out here, getting closer and closer to the x-axis, but never touching it. All right. So now what do? We know that we're closer and closer to the x-axis way out here, but we have to cross the x-axis right here. So what that means is, now the book they didn't give us a specific point. So it goes out this way, and it's going to approach the x-axis, get closer and closer, which means that it's going to curve, down a bit, coming back this way. But we know it has to come back and cross the x-axis right here. That's set. So we will do this, and I almost made it through it up. And we've got an asymptote, so it's got to do that. Let's put my zero back here. There's green. Zero is green. Alright, so let's start at one end. Okay, so we've got that piece. Then, as we go, as we work our way across here, every time we cross an asymptote, we need to jump to the other side of the x-axis. So, if we were way up here, on this side of this asymptote, when we cross the asymptote, we got to be way down here. So we can come this way, but we don't cross the x-axis here. So somewhere along the line, we're going to have to make a U-turn and go back this way. When we get to another asymptote, and cross the asymptote, we're going to cross the x-axis. If we were down here on the right side of this asymptote, we're going to be up here on the left side. And we're coming along, and we cross the x-axis here, and keep going this way. Cross an asymptote, cross the x-axis, we're going to come from up here. But we don't cross the x-axis, so we're going to have to turn around and go back. Cross an asymptote, cross the x-axis, and there was no other asymptote or a zero out this way, so we're just going to approach the x-axis like this. And now we have sketched the graph. Hopefully my graph looks like the book. Close enough. And if you really wanted to, and once you have this sketch, if you want to check yourself, you could type it in on your calculator, at least your left and right, and see if the calculator's graph looks anything like yours. And that is how to sketch one of these graphs.